So the next chapter is on inelastic and elastic collisions, and this is chapter 11-3 in the textbook. Okay, so just a quick reminder on conservation of linear momentum. So if you have a system of objects, only external forces can alter the total momentum of the system. So remember, if there was zero net external force, then the momentum was conserved. It stayed constant. So this is the law of conservation of linear momentum that says when the net external force on a system of particles is zero, the total momentum of the system is conserved. And remember, another way to state that is to say that the total momentum of an isolated system of objects remains constant. So, and then again, so applying this to collisions, so collisions, right, that typically happen over very short time intervals. So as long as you look just before and just after the collision, typically any external forces are usually small enough that they're negligible and they can be ignored. So remember, we called this the impulse approximation. Now, when it comes to collisions, we can actually divide collisions into a couple of different types. So first off, there's elastic collisions. So in elastic collisions, both linear momentum and the kinetic energy are conserved in the collision. So typically, truly elastic collisions only happen with like subatomic particles, but if you have things like billiard balls and steel ball bearings, they can actually come close to a perfectly elastic collision. Now, in an inelastic collision, only the linear momentum and not the kinetic energy is conserved in the collision. So in general, the kinetic energy of the objects before the collision is going to be different than the kinetic energy after the collision. And a special type of inelastic collision is when after the collision the objects stick together, and that's called a completely inelastic collision. Now, I'm not going to go through the whole derivation, but if you have elastic collisions in one dimension, so you can use the fact that both linear momentum and kinetic energy are conserved. So basically, if you imagine you have two objects that are going to collide elastically, so you've got one equation that describes the conservation of linear momentum. So the linear momentum of object A plus object B before the collision equals linear momentum of object A plus object B after the collision, and kinetic energy. So kinetic energy of object A plus object B before the collision equals kinetic energy of object A plus object B after the collision. And you use those two equations, plug in your M's and your V's, and do a little algebra. And you can come up with these equations here. So the prime means after the collision. So the speed of object B after the collision is equal to the speed of object A before the collision times this combination of the masses plus the speed of object B before the collision times that combination of the masses. And again, you have something similar for object A after the collision.